Sorry.
It's on!
It is?
Yes.
Oh, hi guys! Let's go back and look at a couple of these reactions for net ionic equations. So the one that we looked at in class today was the equal volumes. It was question 33. It was equal volumes of equimolar phosphoric acid. So we know that phosphoric acid, let's actually do black, H3PO4 plus potassium hydroxide. So then I have plus KOH. Because it says equal molar and because it's equal volume, that equal molar concentrations mean that, why are you moving it? Okay. So this means that this polyprotic acid is going to lose one ionizable hydrogen at a time, okay, just one. So when I break this down, it's going to break into hydrogen ion, and then it's going to break into dihydrogen phosphate ion. So I'll have H2PO4 minus. Now, it's a weak acid. This is not one of the 7 strong acids that you were asked to know. So because of that, I am not going to break this apart. You can only break apart strong acids or strong bases or an ionic compound when it's aqueous. So this will break to, over here on my product side, I'll have salt and water. So I'll have KH2PO4 plus, that'll be aqueous, plus water. So that's my molecular equation. My next goal is to write that net ionic equation. So if I do that, I cannot break apart a weak acid, so I leave it intact. I can break apart KOH, it's a strong base. Yeah, so I can have K plus OH. And then we should have aqueous on both of these. For some reason, this is not calibrated very well, I apologize. I can break apart KH2PO4 because it's an ionic compound. So I'll have potassium and H2PO4 minus. And then I can't break apart water because it's a liquid. So the only thing that I have in common on both sides are potassium. So my net should be phosphoric acid plus hydroxide will yield dihydrogen phosphate ion plus water. That's my net. Some of you asked on the first balancing of that AP Chemical Equations Challenge where I posted the key on number 17, some of you thought that I did that wrong. I want to go through it. On 17, it was a solution of sulfuric acid, so I have H2SO4. And then that was reacting with barium hydroxide. I have a strong acid, and then I have also a strong base here. But this is a polyprotic, and it told me in 17 that it's a solution of sulfuric acid added to a solution of barium hydroxide until the same number of moles of each compound have been added. So I have equal number of moles here. Because of that, again, equal number of moles, you should go one hydrogen off at a time. So when I do this, I'm really going to make BaHSO4 plus water. Because I'm only getting off one, or I'm only getting one hydroxide, or one hydrogen ion at a time, okay? Because this is a strong acid, I want to break it apart into its ions. It is a strong acid, so it can break apart. But when it breaks apart into ions, because it's equal concentration, it's going to be H plus HSO4 minus. So the reason that I broke it apart here is because it's a strong acid and I can break it apart into ions. The reason that I didn't break it apart here on the H3PO4 is because it's not a strong acid, so I can't break it apart. It is a weak acid, and they very slightly will dissociate. So we just don't even want to show it at all, because the dissociation is probably going to be so small. For the most part, it'll probably be very negligible. So that's the difference between those two. Okay, so a strong acid I can dissociate. A weak acid, just don't touch that. Okay. All right, I will post a key, like I said, to those questions that were review. If you have any questions about any of them, then just comment on your blog or send me an email, and then I can try to help you out. Yeah, so if you need anything, let me know. Have a good night. I'll see you tomorrow.
Hey, don't care.
I can't turn it off.